just see my screen is visible. Screen is visible, madam. My screen is visible. Voice is
Yes,
clear.
yes, sir.
Voice is clear.
Yes, sir.
Okay. So see, this is the discussion about the unit number 4. Uh, in that we are going to learn ARM, that is Advanced Risk Processor. So before going to the detail of ARM, first we see the history of controller and then how the electronics embedded system is switching their whole product development toward the ARM, because there is a special features is available in ARM which is very suitable to the portable devices. The very good example of ARM is your handset, that is different mobile. So for different mobile, what are the things which is expected, what are the things which is important. So we will see the step by step discussion for in this whole discussion. So for this, first we know that what is the controller. So controller is just one chip. On that chip we have the CPU, RAM, ROM, IO port, timer and serial port. But this chip is available, and people are that interfacing the maximum number of devices. So maximum number of sensors, maximum number of input output devices is required. So this space related to the microcontrol, that is, if you see the complete, if you see this specifications, so in these specifications, the ROM is there, RAM is there, 8-bit IO port is there, and there are different 4 port is available. So and timer is available also, timer and counter is available. So if you see that, in timer and counter, all these are the small blocks which is available on single chip. As and when I required for implementing some system, so I am using this timer, I am using as a counter. So it is a mini, and for specific type of application we can use this microcontroller. uh, if you see the difference between microcontroller and microprocessor, again we have the basic units which is available, that is memory is very important part of the whole discussion, input is very important, output is very important. So if you see the processing unit, so output is nothing but one type of display which is we are using in maximum type of instrument. Input, there is a sensor input, there is a relay input, there is a keyboard input, maybe the voice is one of the input for voice control devices. So lot of types of input is there, and after that we are going to store some type of last records. So for that we need the memory. So this is the diagram which we observe for this CPU microprocessor, and under this microprocessor we have this microcontroller. Screen is visible, madam?
Yes, sir.
So this is generalized difference between this microcontroller and microprocessor. After that, these are the uh, again on single chip. People are giving the solution for embedded system on single chip, in that they add ADC, DAC, clock, RAM, and ROM. So this is one of the diagram. From this diagram, definitely you understand on single controller these are the different objects we have. So in these objects, it is what you say that they are putting all these things on the, what you say that on single chip. So we can we can use this whole system. That means if you see, uh, for the CPU, we can write the code for DAC, in that there is a block and special register is available. So this single controller, inside that single controller, different registers which is available to enable the DAC. Different register is available to enable the DAC, clock, RAM, ROM. So all these things is available on single chip. So whole world of this electronics is diverting toward these single chip solutions. So this is the diagram which shows that all these things is available on single chip, and these are the some applications which is people are using, that is lot of automation in home appliances, USB, telecom. So these are the only sample example which we are using this. For specific type of application we are using this type of controller, that is microcontroller application. Now to understand this processor we need to go through these two basics. So as we are aware that these are the two basic fields to understand this processors and controllers. So it is a combination of processor and controller. So as you know that uh, there are different types of arm is available. So what is the arm, how, what are the different categories of arm, and how we are switching for cortex. So our fourth unit is the arm cortex. So before going to the arm cortex we will just see that what exactly the arm is there. So what is mean by arm? So there are two types of designing philosophy is there. One is called as a sys philosophy, that is what you say that uh, complex instruction set computer and reduced instruction set computer. These are the two different philosophy which is available. So what exactly these philosophies? So see, in RISC philosophy what is the things which is available? See, there are uh, see that there are the CPU is available. So every time what happened during this CPU, so when we want to execute some function, so always we are giving some instruction. Let us see some example. Suppose I want to add 2 plus 2 in any type of controller, and what is the answer? Answer is 4. So what is the procedure to add these things? So in our brains, if you see that there is the same calculation we will done in the uh, any controller. So we are identifying some space for storing these two, we are identifying this space for this storing 2. So let us consider these are the two registers which is available. So A is one register, B is one register, and C is one another registers which is available. So we are storing whatever the number which is available for addition, which is 3, maybe 4, whatever it is, generalized program. So when we use this 2 in A register, second 2 is in B register, and then we are going to perform the operation. To perform the operation, again we need to check that what is mean by this addition. So is it possible for the controller directly add these decimals? So not. So first it converted into the binary, then binary is shifted, and then the performance of this addition is there. So one's complement, two's complement, and lot of operations which is available for addition, multiplication, division. So by using these different operation, your our controller is going to add these two things, and we got the correct result. So for that we need the structure, we need the registers which is available on the different for storing the data. So for 8051 controller are very initial stage of the controller, always when we perform some operation, so it is expected that to communicate to the memory. So each and every time you need to connect to the memory. So in CISC philosophy all these operation is performed by using this memory connection unit which is available in a CPU type, which is available inside this controller. But when we perform this operation we need the what you say that the number of cycles. So as you know that there are basic three operations in all the controllers. That operation is fetch, decode and execute. So to perform this fetch, decode and execute, so we need a number of cycles, that is the frequency which is available and how many number of cycles is available. In this type of philosophy, when we interact all these operations to the CPU, then it take the maximum time to fetch, maximum time to execute and decode. So the memory is stored, and always every time you are connecting with this main CPU, and then main CPU is connected with the controller memory, so that needs number of cycles, so it, that means required more time to process. But in sys type of architecture, this is the main difference between sys philosophy, design philosophy and RISC philosophy. Here we are giving the number of registers, and that number of register is used to store that data. So here we are reducing the number of cycles and increasing the speed. So speed increase, if you want to increase the speed of any, what you say that the process, so it required the less number of cycles. So how we reach to the less number of cycle? So we reach to the less number of cycle only to reduce the, always we are giving the interference to the CPU and call them to the for read the memory, so that we separate this memory unit, and that memory unit and number of register is increased, so that always it is not expected that to always this interrupt to the CPU. So there is a separate register structure which is available in this advanced type of controller. In that, number of register is more. So number of register more means the storage capacity for each type of register is different. So these are the register structures which is available. So very main important point for this processor performance, if you see, this is the processor performance: speed, throughput and peripheral interaction, pipeline advancement. If your pipeline advancement is a main part of increasing the speed, so all these are the key performance parameter. That is, key performance means what exactly the which type of things we add in the structure, so that we will get a best performance, reduced time for processing. So these reduced type of processing is available in these types of structure. So after that, after that understanding of these points, now the people are thinking about the architecture. Now what is the meaning of architecture? Anyone can tell me what is the meaning of architecture? Have you heard this word architecture? When you design any construction, so we need the architectures. Architecture give you the block diagram of that whole unit, how this block diagram is, and where is, if you are constructing any mall, business mall, the architecture is different. If you are constructing one home, so that architecture is different. That means depending upon the application, architecture designing their drawing, and it is expected that they give the full utilization of the space according to the application. That is called, we say that, the architecture evaluation. So evolution of this architecture is nothing but people are facing some problem in previous architecture, then they come up with the next architecture. So again there is a version 1, 2, 3, and from that version we reach to the different types of ARM controllers. So these are the points which we uh, discuss in last 2 minutes. This is fast context switching, that is smaller process environment handling, powerful assembly language programming facility, reduce requirement of compiler, flexibility of processor operations via microcode, powerful and fast floating points, reduce memory requirements, that is program required less memory, improve the cache memory performance due to the smaller program size, and reduce bus traffic. So these are the some points of CISC. And now in risk, what exactly the things? So here is the two very important find is that which I am trying to cover you the large register files. So why we need the large register point? To store the maximum number of elements. That's why the flexibility is given in here risk. So emphasis on the register oriented operations. So most of the operation is very close to the register operation. It is not always interfering the main memory unit. Main memory unit is devoted for only the specific operations. For very high end operation it is required. So most of the operation is on the registered. So register is very important part of the RISC architecture. Instruction that primary execute in a single cycle. Here it is very important load and store instructions for memory access. So load and store means it is one type of what you say that instructions which we use load and store operation. So fixed length instruction that do not span word boundaries, hard coded logic, pipeline instruction cycle. These are the some features of RISC architecture. Now this is advantage. What under the RISC architecture? RISC architecture is nothing but the ARM architecture. So we are dividing this design philosophy in CISC and RISC. So under the RISC, these are the different ARM controller is available. So I am explaining here the very what you say that what is the risk, and under this what are the things which is available under the risk. So under a risk category there are ARM 7 is available, ARM 9 is available, ARM 10 is available, and after that version of ARM 6, ARM 7, 6, 7, 9 and 11, then people are come up with the Cortex. So it is the part that whatever the things which is not available in ARM 7, it is available in ARM Cortex. So ARM Cortex, now most of the industries they are using ARM Cortex for the different types of application as per the application requirement. So these are the things which is the advantage of the risk, that is faster processor design, fast instruction execution, fast decode, simple control unit. So these are the different improved optimization compiler support, reduced pipeline branching penalties, and improved subrouting parameter. So these are the all risk advantage. Now if you see the summarized things of risk and sys, so here the complex instruction taking multiple cycle. So due to this risk is what you say that one parameter. Here is a simple instruction to take only the one cycle. So that means number of cycle is reduced, so processing time is fast. Here the processing time is high because number of cycle is multiple. Any instruction may be referred to the memory. Here the instruction is not referred to the memory, so here it is only the load and store references, that is register architecture is there. So non pipeline or less pipeline, here highly pipeline. So if you see the different features of race, here we take care that how we reduce the processing time and increase the speed. So what are the things which is available to increase the speed? So all this modification is done in the architecture, and that architecture is nothing but the ARM 7. So variable format instruction, here fixed format instruction, many instruction and the modes, here the few instruction and the modes, complexity in microprogram, complexity in compiler, single register set, multiple register set. So risk design philosophy, that is the instruction pipeline register and load and store architecture, these are the major point. Now early days what happened, this risk and sys philosophies is fighting each other, or they are diverting their whole things. So but combination of the advanced risk and combination of advanced risk and sys, we are taking the advantage of both the units, and we are come up with the that is arm. So then jointly, that is some parameter from CISC we are taken, some parameter from CIS risk we are taken, and they combinedly come up with the advanced risk machine. So advanced risk machine is one of the architecture which is available. It is not any company, they are giving the only the core architecture of arm. So if you see on a website, arm clients, so hundred of thousands of companies using arm architecture. It is not the arm product is there, and architecture is different things. But so advantage of both the philosophy we are combining in arm designing. So very important thing is that low power, high code density, reduced die area, hardware aspects. So adaptation of standard bus architecture and hardware debug technology. So these are the some advantage of this arm. So under the software development we need software is available, and the thumb instruction, conditional execution, enhanced instruction, inline barrel shifter. So these are the some software developer aspects which is available. Now this is the typical embedded hardware which is available for any type of devices. Here if you see, there are the ARM processor is available. If you see, there is a ARM processor. After that there is a AHB bridge is available. Now along with this there is a ROM, SRAM, DRAM. These are the different memory unit which is available, external bus. Now here if you see the controller, peripheral and buses. If you see this complete architecture, so most of the part which is available on the ARM processor, it is having the separate what you say that the register unit. It is the for the memory control, it is for the external discuss external interfacing. And along with this there is a one line which is connected to this whole units, that is real time clock, serial UART, ethernet counter. So it is connected to the via AHP arbiter, and whole this unit is controlling this type of the what you say that sensors, or inside that there are the blocks which is available. When we program this block by using the specific type of register, then we are using these types of controllers, these types of what you say that the features. So ethernet, when I want ethernet, so I am using specific type of registers, and that register is available in the data sheet. So according to the requirement we can program. This is the typical hardware which is we use in the embedded system. So a large uniform register file, this is very important feature of ARM. Load store architecture. What is mean by load and store architecture? So load and store architecture is very important part of the discussion. So if you see here, the load operation copy the data from load instruction, load operation copy the data from main memory to the register. Now, so if you see the structure of any device, there is a main memory which is available. If you see, there is a main memory. This is, suppose let us consider the main memory, and these are the different register is available. So register is a temporary what you say that memory. We can use that register for the temporary storage. So there are total 37 register is available in ARM 7. So this is the memory. So what the load means, what load means, copy the data from, copy the data from main memory to the register. And store means what? Store means from register data from a register into the main memory. So it is a store operation. So it is store operation. It is load operation. So try to understand the meaning of these things, because when we deal with the always with the memory, there is a number of cycle is different, and when we deal with the registers, so that's why this load and store architecture is very famous in ARM. Simple addressing mode, uniform and simple instruction fields. Now these are the units which is available, and now we will see the exactly the what are the different version of ARM is available. So if you see under this first version, so version 1 is available. So under this first version, if you see the ARM v1, so under this version the ARM 1 is there. So what are the features of ARM when initially it is developed? It is first ARM processor. It is the size of 26 bit addressing. So people are facing the problems, again they come up with the version 2. So in that 32 bit multiplier and 32 bit coprocessor support is available. On chip cache memory and automatic swap instruction is available. Only 32 bit coprocessor, again come up with the second version which is very close to the second version, that is ARM v2a. So on that they are adding a automatic swap instruction along with the all first features and coprocessors. So if you see the development of this whole things, development of this ARM version up to the ARM v6. So ARM v6, finally we reach to the ARM 7. So most popular device in the ARM is ARM 7, because it supports to the most of the features, that is superset, thumb instruction, enhanced multiple instruction, extra DSP types. So whatever the requirement which is available as per the application, people are using these types of the devices. Now if you see this evaluation diagram, that is development of ARM architecture. So early ARM is 1 2 3, after that 4 and 40 ARM is developed. So under this category, if you see there is ARM 7 TDMI, ARM 9 TDMI, ARM 722. So these are the different category which is supported to the thumb instruction. This is thumb instruction support. What is thumb instruction support? Thumb instruction is what you say that different types of categories of instruction is there. There is 32 bit instruction, 16 bit instruction, 18 bits instruction. But in this type of instruction, what happened, we can use the half portion of a instruction, that is, as and when I required 16 bits, so I can use that 16 bit for some type of instruction. That's why it giving the flexibility. So it reduces the memory of that program. So that's why this different types of thumb instruction is available, and it is supported by our architecture. So improved ARM thumb instruction under the category of 5T. Now the next category of this 5TG is ARM 9 10, and after that it is the development of Cortex. So these are the some nomenclature which is available. So it is just for your information. So here we are trying to understand the ARM, what is the ARM, how the ARM is important, and what are the different aspects related to the ARM. So in concluding discussion is that ARM is one of the device which is very important for the less power, that is less power is required for ARM, very limited registers, that is register set is high, it is load and store architecture. All these features is required to increase the speed of the processing. When we increase the speed of the processing, that is the time required to complete the process is very less. So processing time हमको कम करना यानी speed is fast is there. So these are the things which is available on ARM. So next, just it is for your just for your understanding. These are the just features of different category of ARM. Now I hope that you understood the information related to the ARM. Now we have a actual discussion on ARM Cortex. So ARM Cortex is what? It is real time. It is two types of discussion we have. Now ARM Cortex M3 based microcontroller, that is Cortex is what? So Cortex is the next version of the ARM. So now what is Cortex? To understand Cortex, to understand architecture, now this is the objective, to understand the concept of interfacing of LED and 7 segment pin connect block. So how many of you know that what is how you program the any controller? So when you do the programming, always you are trying to connect that program. When you are writing the program, so you are playing with the registers. So register is 8 bit, register is 16 bit, register is 32 bits. So that means when we program these registers, so according to that program and setting of register, your controller is working. So what exactly, there is a one chip which is available, and inside there are lot of register. I want to use only the this one registers, and there are 40 pins, maybe 64 pins which is available, 28 pin is available, lot of packets is available for the controller. So as per your requirement, you can use how many IOs you want in your application. And when we want to connect any sensor to this type of controller, so here is a flexibility in ARM is one pin is act as a parallelly 2 3 functions, and it is called as multi functions. So see, if I am going to use the 40 pins, so one pin is giving you the 2 and 3 functions, different functions. So how I can use these 3 functions? So here is one register is there. So that register is called as a pin cell register. So pin cell register is one of the registers which is used to select the pin function. So pin select is one of the register which is used. There are different 3 pin is available, register is available for pin select. So why we need the pin select? Because in the architecture it is mentioned that one pin is we can use for the different application. Suppose I want to use for only the input output, so I can use. Suppose I want to use this same pin for transmission and receiving purpose, so you can use. Suppose I want to use this same piece for as a USB, USB protocol. Suppose I want to use this same pin as a different types of application. So how you are using these type of application? So here the register is, that means there are 16 bit register is available. 16 bit means it start from 0 and end on 31. Always this is the structure which is available. So it start from 0 and end on 32. So it is 8, 16, 24. So if you see, the specific bit is available for selecting the function here. So here the, that means in this processor, I don't know, I am giving the generalized things. So if I am setting 0 0 here, so there are initial 2 bits. So when I am setting these 2 bits, so my operation of this pin is different, that is 0 0. When I am selecting 0 1, my operation is different. When I am using 1 0, my operation is different. When I am using 1 1, so operation is different. So depending upon the setting of this register, this 4 operation is operated. Nah. So and if you see, these type of architecture is available, only this type of feature is available in the ARM. In other type of controller, if they are using the ARM architecture, that is ARM philosophy, or ARM cortex part, that is ARM core part. So ARM is a just architecture which is giving all these feature. The companies of ARM is Philips, they are using this type of architecture. ST Microelectronic, they are using this controller. Lot of controller is available in the market, they are using these types of architecture. Architecture means core part, it is not one company, it is architecture. So these are the things which is available in ARM. So we are trying to understand these things. So features, there are different types of blocks which is available: system control, clock, power control, GPIO, and pin connect block. So here the generalized discussion of ARM cortex, that is ARM cortex is the one controller which is normally we are using in a lab, that is LPC 1768. So this is one of the controller under the category of Cortex M3. Cortex M3, I am representing the controller. Under this Cortex M3 there are three different types of categories which is available. So we will see that things. So based on microcontroller for embedded application featuring high level of integration and low power consumption. The family of ARM is famous for low power consumption, na? So ARM Cortex M3 is the next generation core, offers system enhancements such as enhanced debugging. These are the some feature, you can just read it. The LPC is supporting for frequency up to the 100 megahertz. ARM Cortex M3 CPU incorporate three-stage pipelining. Use a hardware architecture with a separate instruction and data buses, as well as the different types of bus architecture. So the ARM Cortex CPU always also includes an internal prefetch. The peripheral component is 512 KB flash, that is 64 KB data memory, Ethernet, USB 8 channel is available. These are the specification of LPC 2148. So in um, in some application we need this UART, we need the CAN protocol for communication, SSP protocol, SPI interface, I2C bus. All these are the different types of protocol which is available for the communication to the sensors. So uh, again ADC DAC is available, so 12 bit ADC, 10 bit DAC is available, PWM controller is available. So inside all these things is available according to the packages which is available. It is available in 64 pin packageable, 100 pin package. So LPC 214 is available. So these are the features of ARM, so it is listed here. These are the serial interface which is available, that is CAN, SPI, USB, two stage SPI, I2C. So serial interface is available under this category, Ethernet, MAC. Now for the bus architecture, so I2C bus is available. Inter IC sound interface, that is I2S is also available. So if you see this Cortex, so lot of features and lot of things is there on chip. If your application is related to your what you say that multimedia interfacing is there, sound interfacing is there, display interfacing is there, tracking is interfacing is, so all these application we can we can use these types of controller as per your application. So all these things is available. So if you see the 70 general purpose IOs, that is which I told you, they are 64. So in input output pins is available 70 general purpose, 12 bit ADC. So all these are the features which is available. Now what are the application here? Lot of application, but some of the I listed here: the e-metering, light industrial networking, alarm system, white goods, motor control. All these are the different application we can use for. In that we are using this LPC 2148 1768 ARM Cortex. This is the very important diagram. which is very important for you people to see. Here if you see the multi-layer and matrix, if you see here complete diagram with full understanding, this diagram is divided into two part. This is one part which is on chip features is available, that is what you say that the SPI, UART, CAN, I2C, again timer, counter, PWM, 12-bit EDC, pin connect block, oscillator. Here the UART2, I2S, it is a timer, Ethernet, system control, motor control, DAC. So these are the different peripheral, on-chip peripheral is available. And to control this on-chip peripheral, there are two types of what you say that buses is available. AHP bus, that is advanced risk bus, it is called as a AMBA structure, advanced bus control architecture. And here the whole these control is connected to the ARM cortex. If you see there are different types of buses is available. One bus is available here, system bus, here here master, all these are the connected to the master. And this diagram, if you understood this diagram, so you understood most of the arm cortex things. So one part is a peripheral connected on chip and another part is a controlling. So in under the controlling there are USB है, crystal oscillator है, JTAG interface है, ports है, debugging है, and this is the complete diagram of ARM Cortex 3. So if you want to just go through this diagram, and this diagram is asked in your exam, so just see that you need to mention this some of the part and which is available, what you say that the different peripheral which are available on chip. So again I told you that architectural view is there. So AHB light bus, that means it is mentioned what exactly the architecture and how it is going to be operate. So if you see there are AH light bus, three light buses. So ARM Cortex include the three AHP light buses. One is called as system bus, another is called as I code bus, and another one is called as a D code bus. So these are the different buses. Bus, what is mean by bus? Bus is a communication between the devices. Maybe it is used for the internal communication. So that all is called as a bus, is the communication inside the chip. So there are different types of buses available. So by using that bus they are exchanging the information, sending the message. After that when you want to this interact, so AHB matrix is there to connect the ARM Cortex buses and other buses masters to the peripherals. So on chip peripheral, that is SSB, USB, timer, counter. After that I2S bus, I2C bus, all these are connected to the AHB. So all the description which is I told in a previous explanation, so all this is given in the written only here. So on chip flash program memory, so all these are the features. So if you go through the one by one features, then it is given that features. So and uh, these are the features. Now again here is a memory protection unit is there. So after this peripheral there is a separate unit, memory peripheral unit, memory protection unit. After that nested vector control interrupt. Now in previous version of ARM only they are using this vector interrupt controller, but here if you see it is a nested vector control. This is very important feature of ARM family. What exactly this nested vector interrupt controller? When you call any interrupt, so interrupt is very important part of any processing unit. So as and when I require the service, so immediately I interrupt the function of the processor and I call for the different types of the services, and that is called as a priority. So priority is very important. If you look toward your mobile and see that what are the highest priorities given, the highest priority is given to the call. Parallelly, you can execute the order function, multimedia, you can listen the song, you can observe the song, you can play with some type of document which is available, Excel, Word. So lot of features which is available, but above all the highest priority is given to the receiving and transmitting the call, because this unit is used for the communication. Along with this, you are adding the different features in that unit. So when you are defining the priority, so in that case you are going to use this some type of protocols and some type of what you say that rules to give the service, and when the service is completed, again back to the original position. So that is going to be a one type of process which is always available in all types of controllers. So for that, calling the interrupt and restoring this, completing that unit, for this you need a maximum time. So that time is reduced by using these type of nested vector interrupt controller. So initially that time is more, that 2 3 bits you use, but in this nested controller it reduces, and that's why the switching of device from one working to the another working is a very easy task. That's why this feature is available, and most of this controller is used for the what you say that mobile applications. So this is the part which I feel that which is very important for you, and there are the different types of this interrupt is available. So control system exempted peripheral, so 33 vectors, 33 vector interrupt is available, 32 programmable interrupt priority levels, relocated vector table, non maskable interrupt, software interrupt. So these are the different categories of interrupts. So there are different interrupt sources is available again. So when you play with this whole system, definitely you understood that what are the different types of interrupt sources is available. My voice is clear, screen is visible.
Yes, sir.
So see, so these are the different pin block is available. So I'm giving this, the pin connect block is, pin connect block is a register set. So in that just for 12 ADC, 10 bit ADC word. So these are the some features which is available. So these features and this detailed discussions of each feature it is given on this this complete PPTs. So all these things is available, and this is how to use it. So some discussion and features is given. So pulse width modulator, how it is going to be used. So there are features and explanation is given under this complete uh, discussion. So see, this complete presentation I am sharing with you. It is not what you said, I am going to explain all these things. uh, so all these features is available, and if you see the syllabus, so I have the syllabus copy. So if you look toward this, just 2 minutes, huh? So that this is screen is visible, madam.
Yes, sir.
ARM Cortex, ARM Cortex Design 2, and this is a real word interfacing. So these are the three unit which is available, and under this three unit, concept of USB CAN here a smart. That means if you see that here is only what you say that how the USB is interface, how the CAN is detailing. All these things is given in a your PPT. So the questions also I made one what you say that notes for you people. So if you see the notes of the unit, so this notes is available on unit number 4. So this is one word document. So here the syllabus is there. After that syllabus there is a question bank is there, है ना? And draw and explain the CMI structures Cortex series. Draw and explain the interfacing of diagram 7 segment. Compare the ARM7 and Cortex M. What is the need of operating? So after that I'm attaching the question answers for then what exactly the question and how you are writing the answer for this. So it is given here. So CMI structure, what is it? Is a Cortex microcontroller software interface, support developers and vendor in creating the reusable software component for ARM. So this is the thing which is available, the what exactly the diagram you need to, what are the different types of layer which is available in CMI. This is divided into three basic functions: core peripheral access layer, middleware layer. So what exactly you want to write, this is the diagram, and these are the things which is. Now second question, so what is exactly the pin? Draw 7 segment, there is interfacing. So there is a question answer notes is available, and detail of the this whole things is available here. RGB and material is there. So you need to go through this whole things for understanding, and question bank is also given in the that notes on unit number 4, 5 and 6. So just you go through that and see that when you are writing these things, so it is expected that so आंसर क्वेश्चन जो भी आपको मटेरियल अभी है आपके पास, सो यस यू राइट डाउन एंड जस्ट शो टू मी सो दैट आई विल चेक दैट होल थिंग्स and I consider this whole discussion or whole work is as assignment on you. So unit number 4 question and answer, unit number 5 question and answer, and unit number 6 question and answer. So all these things which is for you, and just you go through this. So this is unit number 3. So write short note on USB. After that it is protocol, what type of protocol, CAN protocol, this is very important. Last unit, any question from your side, madam?